Good morning, students. So we will start our experiment 2, that is experiment 2, that is determination of strength of sodium hydroxide by standardized oxalic acid solution by conductometric process. What you have done in experiment 1, you have done determination of concentration of sodium hydroxide by oxalic acid solution by normal titration process, acid base titration process by using some indicator. But today we will calculate the concentration of concentration of HCl by standardized sodium hydroxide solution. Okay, so what is the heading? That determination of concentration of HCl by standard sodium hydroxide solution by conductometric method. Okay, by conductometric method. Okay, so before starting this theory, I must remember you that determination of concentration of HCl by standard NaOH solution, we can do the same process by normal titration process. That means by using glass apparatus like burette, pipette, conical, etc., and by using indicator. But today we will do the same process by instrumentation method, that is conductometric process. Okay. Now HCl is secondary standard, sodium hydroxide also secondary standard. So we can't directly go for the titration process with HCl versus NaOH until and unless we can get a proper concentration of any one of these two. Particularly for this experiment, we will calculate final concentration of HCl with the help of standardized NaOH. So initially we need to standardize sodium hydroxide. Okay, sodium hydroxide is secondary standard base. So we need to standardize sodium hydroxide with the help of one primary standard acid. And today we will use oxalic acid. Okay, today we will use oxalic acid. So initially we will go for the titration process of oxalic acid versus sodium hydroxide. Then we will calculate the concentration of sodium hydroxide. Then we will go to the instrumentation process to get the concentration of HCl. Okay, mind it, you can do the same process through glass apparatus, that means through normal titration process. But today we will do one instrumentation process, that is conductometric method. Before going through in details, first I will make you remember that what is conductance. You know what is conductance? Conductance is actually the reciprocal of resistance. Okay, conductance is actually the reciprocal of resistance, and unit of conductance normally expressed in Siemens per centimeter. Okay, unit of conductance normally expressed in Siemens per centimeter. Conductance means, let us say you switch one electric appliance, switch it on, and then it will start lighting, or your fan is start moving. That means when you switch switch it on, then some electrons will flow through the wires and it will give power to that electric appliances. It will start moving or it will start lighting. Okay, so flow of electrons, in short, flow of electrons will termed as conductance. But for solution, particularly for solution, here flow of cations and anions will be termed as conductance. For solution, flow of cations and anions will be termed as conductance. Let us say you have HCl solution. So conductance will depends on flow of H plus and flow of Cl minus. Let us say you have H2O. So conductance depends on flow of H plus and flow of OH minus. So in short, that when you prepare one solution of HCl, aqueous solution, it will dissociate into H plus and Cl minus, and that is the count of conductance. And what is the movement of H plus inside the solution? What is the movement of Cl minus inside the solution? That will be the count of conductance for solution. That actually means, one second. হ্যাঁ স্যার আমি ভিডিও বানাচ্ছি ক্লাসে। So movement of H plus and movement of Cl minus inside the solution will be termed as conductance. Let us say you have taken NaOH, that means movement of sodium plus and OH minus will be treated as conductance. So particularly for solution, movement of ions will termed as conductance. That actually means, so what are the dependents of conductance? That actually means if ions are of smaller in size, that means conductance will be higher, because smaller size ion can move more faster than the bigger size ion. So if ion size is smaller, then conductance will be higher. If ion size is bigger, then conductance will be lower. Okay, now on the basis of this theory we will do one simple process. First, in step 1, obviously we will go for the titration of sodium hydroxide versus oxalic acid, sodium hydroxide versus oxalic acid, to get the concentration of sodium hydroxide. This is a very traditional process, and we have also done the same process in our experiment 1. So after this titration we will have the concentration of sodium hydroxide. Now with this known concentration of sodium hydroxide, we will go for a simple titration process by conductometry. What we will do, conductometry is a setup where it contain one this type of machine. In middle it contain one digital display, and some wire is connected with conductivity electrode. That electrode will be dipped in solution. If you dip that electrode in solution, you will show its conductance in millisiemens unit. Okay, so if you dip this electrode in water, then it will show the conductance of water. If you dip this electrode in HCl, so it will show the conductance of HCl. Okay, normally if you take some amount of acid or base solution, and if the electrode is not dipped well inside the solution, we need to add some water, so that the solution volume mark is increased and electrode is conductivity electrode is completely dipped inside the solution. Okay, so for this process initially we will take HCl. Okay, HCl in beaker. So we take HCl in beaker and we note the conductance of HCl here. Okay, particularly for HCl we will count the conductance in terms of H plus, because H plus is very small size ion, and that acid will show its conductance for the movement of H plus. Okay, now we start addition of sodium hydroxide dropwise. In that beaker where it contains HCl. Conductivity electrode is already dipped inside the solution. Now you just add 1 to 2 drops of NaOH. What happened? As NaOH and HCl react with for the formation of NaCl and H2O. That means the HCl start reacting with sodium hydroxide for the formation of NaCl and H2O. Okay, that actually means H plus ion concentration is decreasing because it is start reacting. H plus ion concentration is decreasing, so it is start reacting with NaOH. Okay, to continue addition, H plus ion concentration decreasing, that means conductance also decreasing. You continue addition of sodium hydroxide, and when total HCl reacted with NaOH for the formation of NaCl and H2O, when total HCl reacted with NaOH for the formation of NaCl and H2O, then if you add one extra drop of NaOH after neutralization, when total HCl reacted with NaOH, there will be no H plus. At that point of time, if you add one extra drop of NaOH, then solution contain OH minus. Due to presence of OH minus, again conductance start increasing. Okay, you continue addition of sodium hydroxide, conductance increasing. Continue addition of sodium hydroxide, conductance increasing. Now if you plot this graphically, let us say in x-axis we are plotting number of drops. In x-axis we are plotting number of drops, and in y-axis we are plotting conductance. In millisiemens unit. Okay, so when there is only HCl in beaker, that means number of drops of NaOH, when there is only HCl in beaker, number of drops of NaOH was 0 and conductance was, let us say, at this point. Now we start dropping NaOH, let us say after 5 drops, after 10 drops, after, or you can say after 2 drops, after 4 drops, after 6, after 8, after 10, after 12. So we start increasing number of drops of sodium hydroxide. Okay, conductance decreasing. When total HCl reacted with NaOH, if you add one extra drop of NaOH, then it will again increasing, but at neutralization point conductance remain fixed for some time, and then it will again increasing due to addition of OH minus. Okay, that means initially conductance decreasing, then fixed due to the neutralization, and again increasing. But mind it, the slope of increase and slope of decrease may differ because H plus ion is more smaller than OH minus. So when medium contain H plus, conductance is little bit higher. Due to the decrease of H plus, conductance decrease sharply, and due to the increase of OH minus, conductance decrease with a mild slope, mild upper slope. Okay, so now just draw one straight line with the best fitted points. Here also draw one straight line with the best fitted points. At the intercept, draw one perpendicular. Okay, now this particular point is actually neutralization point. If we draw one perpendicular, this particular area is actually the responsible for neutralization of the sodium hydroxide. Okay, so this particular sodium hydroxide required for the neutralization of HCl. We will count this from graph, and then we will do again V1 H1 V2 H2 to get the concentration of HCl. Okay, so first we will go through the experimental section. একটু pause করো,
ready,
একটু closer এ আসো. This is digital conductivity meter. Okay, and everything set up now, calibration done, and this is digital display. If you dip this electrode in this solution, then it will give the conductance value in millisiemens unit. So what we will do, first we will throw this solution. Okay, and we will pipette out 10 ml. Okay, we will pipette out 10 ml HCl. 10 ml HCl and pour it in this small beaker. Okay, and we will add some amount of water. We will add some amount of water so that the conductivity electrode is well dipped. We will add some amount of water so that this electrode is well dipped. Okay, now you note the conductance value. You note the conductance. দেখাতে হবে, ডিজিটাল ডিসপ্লেটা দেখাতে হবে, ভ্যালুটা নিতে হবে. You note the conductance value, that is 3.20. Okay, initially 3.20 or 3.19. Let us be stabilized. 3.20 or 3.19. Now we start addition of sodium hydroxide dropwise. Okay, I have taken one burette. Okay, so first note the reading. When there is no NaOH added, reading is 3.18. Okay, or 3.19, whatever. Now I have added 1, 2, 3 drops of sodium hydroxide. Make it homogeneous. It tends to decrease, but somehow due to instrumentation error it is now 3.42. Whatever, write that reading 3.42 or 3.39. It is decreasing. Wait, write the reading 3.42. okay, I am again adding 3 drops of sodium hydroxide. Then I have added, write the reading 3.42. or 6. Again I have added 3 drops, 1 2 3. Write the reading 3 point wait, after homogeneous 3.04. again I have added 3 drops, 1 2 3. then the reading drops to 2.82. okay, again 3 drops, 1 2 3. reading drops to 2.66. again add 3 drops, 1 2 3. reading drops to, let us assume after stabilization it will be 2.45. okay, again add 3 drops. So now reading drops to 3.20. say after stabilization it will be 3.20. okay, again add 3 drops, 1 2 3. say after stabilization reading will be 2.00. okay, 2.00. again add 3 drops. reading will be 1 point, say after stabilization it will be 1.84. okay, again add 3 drops. after stabilization write the reading, it will be 1.65. it is now 66. after stabilization it may be 1.65, or let us pick 1.65. okay, again add 3 drops. so after stabilization the rate of decrease of the reading is decelerated. that means decrease টা কিন্তু কমে গেছে. so let us pick the reading 1.54. again add 3 drops, 1 2 3. now it's increasing. that means my neutralization is completed. Neutralization reaction is completed. now it's increasing. according to theory, initially after addition of sodium hydroxide it will start decreasing and then stable, then increasing. so we got the stable reading at 1.54. okay, we got the stable reading at 1.54. now it's showing 1.60. again add 3 drops, 1 2 3. again the reading is increasing, means 1.64. add 3 drops, reading increasing to 1.67. add 3 drops, 1.71. again add 3 drops, 1.73. again add 3 drops, 1.76. now stop. That rate of decrease of reading when you start addition of sodium hydroxide, it was more sharply, but rate of increase after neutralization it is little bit slower. only 0.2 unit, 0.3 unit, 0.2 unit, 0.3 unit. But rate of decrease, it was 0.10, it may be 0.20, it may be 0.30. But rate of increase after nucleation is only 0.2 to 3 unit. That means your graphical nature will be, there will be a sharp decrease and there will be a mild increase. Okay. So now what you will do, you just count the number of drops I have added. You count number of drops I have added. Let us say I have started with 3 drops. So initially when there is no NaOH added, write the reading in your copy. It was let us say just a page from you, just go through the video, write the reading, and then after addition of 3 drops write the reading. After addition of next 3 drops, but in your copy you write 3 plus 3 6 drops at the reading. In third reading 6 plus 3 9, write the reading. In fourth reading 9 plus 3 12, write the reading. Then 15, write the reading. Then 18, write the reading. So you just go through the video and write all the readings, 3 plus 3 plus 3 plus 3. Okay. And now that is the number of drops I have added sodium hydroxide to the HCl solution for the neutralization process. Okay. But we count number of drops. We need to convert that number of drops into volume. Okay. So we will count that from this period I have added NaOH solution. So we first count that how many number of drops equals to 1 ml. Okay. So let us pick the volume now. It is exactly at 3.5. So let us drop down some liquid. The reading is now 4. Okay. Now what we will do, we will count the number of drops for 4 to 5 ml. That means for 1 ml we will count the number of drops. Let us start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Stop. So at 18 drops, your period reading comes to 4 to 5. 18 drops. 4 to 5. That means 18 drops of NaOH equals to 1 ml. Okay. So you can write, I want to put in here. So you can write 18 drops. You can write 18 drops of NaOH equals to 1 ml. Okay. Now you just go through the video of capturing reading and draw one table. Okay. In left hand side number of drops and in right hand side conductance. Okay. So first it was 0, write the reading. Then 3, write the reading. Then 6, write the reading. Then 9, write the reading. Then 12, write the reading. Okay. So up to your last reading, you just count the number of drops and write the reading in this table. Okay. So this is the table. Okay. Now take a graph, plot. Take a graph, plot number of drops, and here conductance. Okay. So for 0 it was like this, then this. Okay. Draw one straight line to the best fitted points. Here also draw one straight line to the best fitted points. From the intercept draw one perpendicular over the x-axis, and this particular area is our requirement. So take this reading, this portion, this reading. After drawing the graph, take this reading. Let us say this is x drops. Okay, let us say this is x drops. So 18 drops equals to 1 ml. X drops equals to 1 by 18 into x. That means let us say y ml. So y ml sodium hydroxide actually required to neutralize 10 ml of HCl. Okay, y ml sodium hydroxide actually required to neutralize 10 ml of HCl. Okay, now what we will do, we will go to the calculation you write V of HCl into S of HCl equals to V of NaOH equals to S of NaOH. Okay, now V of HCl 10 ml. We need to calculate the concentration of HCl. V of NaOH, that is YmL from the graph we are getting, and S of NaOH we are getting from table 1. That means our neutralization process NaOH versus oxalic acid. So S of NaOH we are getting from table 1. Okay, so this is the total calculation. From that you can get the concentration of HCl. Stop.